Hi, this is Andrea Bianchi from KAIST. I would like to introduce you to a simple project I'm working on to help developer in prototyping physical computing applications. So the idea is actually very simple. When you do some developing in terms of software, we can leverage on comments as a way to basically not execute specific instruction. So say, for example, I'm executing some code here and I don't want this to execute, I can comment out a few lines of code and effectively change the behavior of the software. What I'm interested in is basically to apply the same logic to hardware. We can comment out software to selectively not execute some instruction. So what I would like to do is to comment out hardware as well, so that some specific part of the circuit or some specific components of the circuit become basically invisible in the physical sense. And I don't have to effectively pull them off of the breadboard. I can just comment them out while I am testing the code. So let me show you what I mean with this. We have here in black a custom breadboard, and on the side there are some LEDs, red or green. When they're red, that implies that the row or the position on a row are disconnected. So effectively, even if you have wires or components on a specific row, they don't see each other. They're all disconnected. If it's in green, then the breadboard works regularly like a normal breadboard. So each one of the points on the row are actually connected. Here an example. So here you can see that the first row is connected to a multimeter. Now, when the row is green, the resistance between any of the 2 points is about 1.5 ohm. But when the row is red, the resistance goes up to, well, basically it's an open circuit, okay? And then you can selectively control which one of the rows you want to have to basically be active. So all the dots on that row are connected or disconnected. So here a practical application. I have a low-pass filter composed by a resistor and a capacitor. Now the capacitor is basically it's disconnected from the circuit. When I reconnect it, the low-pass filter works. But when I disconnect it, like now, basically it's like if it's not in the circuit. So I can selectively control when things are there or not without removing them from the breadboard. So in terms of hardware, SwitchBoard has over here a breadboard, is a custom breadboard. Then we have an Arduino and a couple of CPLDs that actually are used for controlling these switches. I'm going to show you in a second. They're on the back of the board. And then we have these dot star LEDs provided by Adafruit. Underneath, it looks like this. It's an array of single pole, double throw switches. This is actually just a prototyping board. I plan to substitute this with solid state relays, but for the time being, that's what we have. So it's a very simple hardware, just the complexity is in the routing, all of these components. The last component of the project is the software. So I'm back to the original sketch that I was working on. Now I developed an extension for Visual Studio Code that allows me to connect directly to the hardware. So I connect to the hardware, to the SwitchBoard hardware, and I see some functionality here on the left. Obviously, I can just turn on and off all the switches at once, but that's not really the main feature of this project. So the main feature is that I can create, basically, selectively, I can choose which one of the rows to turn on. So here I'm going to type pragma and I'm going to say on. And then here I'm going to write an expression, for example, indicating I want to have pin 1, 2, 3 to actually turn on. That's going to be highlighted over here in my code because it becomes green. I can see over here. And then, of course, in the hardware, pin 1, 2, 3 are on. Now I can actually start adding stuff. For example, I could actually have a concatenation of this expression. Say, for example, I also want to have pin number 26, 27, and 28, so on the other side. Or maybe say I don't want to have pin 27, so I can actually remove some of the pin selectively. Or I can also have a range. So say, for example, when I have a range, maybe between pin 10 to 15 to all be included. And as you can see, as I'm typing, they turn on and off directly into the hardware. Now, I can create this kind of expression, but what I can also do is I can save these into a variable. So let me create a definition. So I define, I'm going to call this one subcircuit circuit 1, and I'm going to save all of these. And then I want a subcircuit 1, if I can spell it. And then now this one is referring to that. And of course I can combine multiple subcircuit, like say for example I'm going to have maybe subcircuit 1, and then I'm going to have subcircuit 2, and then maybe say this second part here really was the subcircuit 2. And you can see that it disappears some of the stuff when I'm typing, because if the parser will not, I want to do the opposite, if the parser does not understand what I'm doing, you find an error, actually there's going to be this squiggling error over here, and it's going to tell me what is the error that actually I'm having. And I can also take a look at the logs and actually see specifically there is something here. I cannot have a plus in this language. So I have subcircuit 1, I have subcircuit 2, and of course I can actually add them together. So this one would subcircuit 2. So I have them back together, or I can actually use them as an array. Like, so for example, I have an array notation over here, and I can only get the first pin of subcircuit 2, which is going to be pin number 10. And you can see that over there. And now what I can do is I can turn on things, or I can also decide to do the opposite. Say, for example, I want to have everything on. So everything is on, but I want these guys to be off. And that is going to work the other way around. So you can combine all of these together. And ideally, you also can move this stuff wherever you want to be. And now, if I comment out portion of my code, effectively, I'm removing them. I can comment them out directly, or I can also go here in the interface. And if I, for example, I delete this, it will add a comment for me. So effectively removing this from the equation. So the idea is now what I have, it's a very simple language made of defines and pragma. The define to define a variable, the pragma to use them, so to set a variable on or to set it off. And I can basically map location and then turn them on and off in code directly. Now you might wonder why I use defines. This was a design choice, to be honest, and I'm also considering using JS docs instead. But the thing here is, instead of making a separate library, I'm using the language itself. So this file is parsed by my extension, and these instructions here are basically going to be ignored by the Arduino, because the pragma definition I made are not compliant with the AVR GCC. So basically they're going to be completely ignored by Arduino. And this defines too, unless you're going to use them down here, there's not going to be any textual substitution. So they're not going to be compiled, and they're not going to occupy any space. Now that's why eventually I resorted in using pragmas and defines, because basically they're completely ignored by they're stripped away by my precompiler.